Unit 3.8, students will calculate the derivatives of the inverse trig function using a modified chain rule. So derivatives of inverse functions, this is going to be really kind of confusing, but they just say if f is differentiable at every point on its interval and dy dx is never 0, it's because we'll be playing with fractions, on the interval, then f has an inverse, and f inverse is differentiable at every point on the interval. Now, we're not going to go through this and prove it or anything like this. They're just telling you that inverse functions are going to be differentiable as long as they are continuous at every point. So let's start with arc sine. If u is a differentiable function of x with absolute value of u being less than 1, we apply the chain rule to get derivative of arc sine equaling 1 over this radical 1 minus u squared du dx, as long as the absolute value of u is less than 1, or simply u prime over square root of 1 minus u squared. So a couple of things I want to point out is, one is it doesn't matter if they write it as arc sine or if they write it as this guy. It means the same thing. It is the inverse function of sine, which means it undoes what sine does. So if I asked you for the sine of pi over 2, you would tell me it was 1. If I asked you for the arc sine at 1, you'd give me pi over 2. Okay. One of the things I want to point out to you, let's talk about sine, not inverse sine, just sine. The domain on sine is all real numbers. Negative, positive, all real numbers. The range for sine is -1 to 1. And that is why on this one here, we need u to be less than 1. 1, I can't have a negative under the radical, first thing. And if my value was negative, this is where he'd come from. Because on the inverse, on f inverse on this guy, this is your range and this is your domain. So my domain only goes from -1 to 1. If you're looking for angles, if they ask you about an angle, you would use, since sine is positive in quadrants 1 and 2, you would use quadrant 1 for the positive values and quadrant 4 for the negative values. Okay, that I know it can be confusing, and some of you guys are going to go, oh, we touched on this in, yes, we touched on this in pre-calc last year. So let's look at a couple of examples. A reminder that the y prime for arc sine is u prime over the square root of 1 minus u squared. So our itty-bitty chain rules come in here. We need to know what u is. U is what's on the inside, so 8x squared. And u prime becomes 16x. And now it's just a plug and drag into here. I needed to know u prime, I needed to know u. So y prime equals 16x over the square root of 1 minus 8x squared squared. So in other words, clean this up a little bit, we get 16x over the square root of 1 minus 64x to the 4th. Okay, some students tend to forget that when you have parentheses, or you're like, this is u squared, everything that is u is getting squared, the 8 and the x. And you raise a power to a power, multiply. Okay, this is it. There's nothing more to this than that. We will get to more like application problems. I'm going to watch the video to see how long I'm getting into a video. If I can try and get everything in 20 minutes, I'm going to do it as one, but I doubt that I can get it done that fast. Okay, let's look at another example. Arc sine again. So y prime is u prime over the square root of 1 minus u squared. So u in this case is, I'm going to write it with the constant in front, radical 2 times t, which gives us, I'm sorry, that's just u. That gives us u prime to be just radical 2. Nothing more. Now we can plug it into our problem. So y prime equals u prime, which is radical 2, over the square root of 1 minus u squared, and u is radical 2t squared. So clean it up a little bit, we get radical 2 on top, over the square root of 1 minus, and the square root of 2 squared is just 2, and then we get a t squared. And we're done. This is where you get to go, yay, we don't have to clean up the denominator with that radical. You don't have to do that, you just leave it alone like that. So the problem's not too terribly difficult. What I'd like you to do on this one is pause the video and try this one on your own and see how you do. Okay, so let's see how you did. On this one here, y prime equals u prime over square root of 1 minus u squared. In this case, u is 1 minus t, so u prime is just negative 1. So y prime equals negative 1 over the square root of 1 minus t squared. How did you do? Because this is a 100% acceptable answer. Now, if you're going, oh, I only got negative t squared. No. Remember that this here is a binomial being multiplied by a binomial. So if you wanted to see this cleaned up, we'll come over here and we'll do a little side work. And that 1 minus t is 1 minus t times 1 minus t. So from this, we get 1 times 1 is 1. 1 times negative t is negative t. We get that a second time when we multiply negative t times 1. And then negative t times negative t gives us a positive t squared. Now, don't forget you have a 1 minus there. So all of this is in parentheses. And I have a 1 minus. And when we bring back the radical. Now you can clean this up. So I have under the radical 1 minus. I'm going to go ahead and distribute the negative as well. No, we'll wait. 1 minus, I have 2 t's there, so 2t plus t squared. Now we'll distribute the negative through. So I get 1 minus 1 plus 2t minus t squared. So in the end, under the radical, these two cancel out, and we're left with 2t minus t squared. So y prime equals negative 1 over the square root of 2t minus t squared. So if you wanted to clean it up, that's the cleanup version. Now this, again, this is an okay answer. This is an even better answer because you've done some work. But if this was a free response question on the AP test, you'd be stopping here. Okay, so let's look at some of the other derivatives for arc trig values, inverse trig values. Derivative of the arctangent. The derivative is defined for all real numbers if u is a differentiable function of x. We apply the chain rule to get the derivative of arctangent to be 1 over 1 plus u squared du dx, or u prime over 1 plus u squared. So there it is again. This guy here is the same as this here. They can use either verbiage, so you have to know what they both are. These are the inverse functions of tangent, which means it undoes your tangent function. So let's look at our domain for tangent. Domain. I was going to write tangent, I'm writing domain. Okay, so we have tangent and we have arctangent. The domain over here is, it's undefined at pi over 2, so it goes pi over 2 actually negative pi over 2 to pi over 2. And then these are plus or minus any pi times n, meaning that I can continue this on no matter where I'm starting. I can continue it on by adding pi to each of those. So if I wanted to do the next one, pi over 2 plus pi would be 3 pi over 2, and the next one would be 5 pi over 2. If I wanted to go the next negative direction, it's the same thing. Negative pi over 2, then negative 3 pi over 2. Anyways, it's every 180 degrees it's going to repeat. So, but we have undefined areas at every pi over 2. Okay, so that's our domain, but our range here is negative infinity to infinity. It'll take any value it wants. Now, this becomes the domain for arctangent, and this becomes the range for arctangent. That's why there's no radical under here or no restrictions on the u. Basically, the u can't be 1. I suppose we can look at that. U cannot be 1. Well, it can be, because 1 plus 1. So never mind. That will never be 0 in the denominator, so we don't have to worry about it. No restrictions, because on the domain there is no restrictions. So let's look at a couple of problems here. Now I got away from just doing the derivative and actually doing some problems. So the particle moves along the x-axis so that its position at any time t greater than or equals 0 is x of t equals arctangent of radical t. What is the velocity of the particle when t equals 16? So this is where we go, okay, well, the derivative is going to be u prime over 1 plus u squared. So in this case, u is t to the 1/2 power. Wrote it that way because it's easy to do the derivative. So u prime equals 1/2 t to the negative 1/2 power. Now, because we're going to be throwing this in there and working through, let's make this a proper fraction. So u prime is going to be 1 over 2 radical t. 1/2 tells you the t is under a radical. The negative tells you that t belongs in the denominator. And now we can plug this in. Y prime equals u prime over the other. So this is going to be 1 over 2 radical t times 1 over and the 1 plus radical t squared. Or in other words, we get 1 over 2 radical t times 1 plus t. Because a radical cancels a square. Now we're not done at this point. They do want to know what's going on when t equals 16. So we come in here and we plug in 16. 1 over 2 square root of 16 times 1 plus 16. Gives us 1 over 2 times square root of 16 is 4. And 1 plus 16 is 17. So we have 1 over 2 times 4 times 17. And 2 times 4 times 17, I honestly don't remember, so we'll pull up the calculator. I get 136. So this is equal to 1 over 136. Okay, there you go. And so if we really had to go in there, it would be y prime at 16 equals 1 over 36. 1 over 136. They did not tell us anything about it, minutes, seconds, miles, meters, nothing. Okay, let's try another one. Arctangent again, so y prime equals u prime over 1 plus u squared. And I would highly suggest that every time you do a problem, you're writing this down because it needs to get in the brain. So in this case, u is equal to t, u prime equals 1. How easy is this? So y prime equals 1 over 1 plus u squared, but that's t, so t squared. There's your derivative. Y prime evaluated at 2 equals 1 over 1 plus 2 squared, or 1 over 5. Now keep in mind, you can check these in the calculator and verify you're getting things right. Just make sure your calculator's in radian mode. In calculus, we only deal in radian mode, so make sure you're dealing in radian mode as you go through these problems. So there's your answer on this one. I think there's, I think there's one more, but we have more than one. Okay, and so we have the next one, derivative of the arctangent. If f of x equals the arctangent of 3x, what is d dx? So they're just asking for a derivative this time. So again, y prime is equal to u prime over 1 plus u squared. Well, I'm not going to pause. You go to pause. Pause it, do the problem, see how you do, and then when you unpause it, I will be working through the problem. So how did you do? So you should have gotten u equaling 3x, so u prime is only 3. So y prime, well in this case we'll do f prime of x, is equal to 3 over 1 plus 3x squared. Now if you got this, you're good. You're good to go. Now if you try to clean it up, make sure you're cleaning it up correctly. That squared goes to the 3 and the x. So if you clean this up, you would get 3 over 1 plus 9x squared. So either one of them is a good answer. I'm not going to argue over that one. Now if you got 3 over 1 plus 3x squared, you made a very common mistake. When students write this, they'll forget the parentheses completely, and they write 1 plus 3x squared. Now, whatever u is, you got to square it. If you have to, at this point here, go, well, u is 3x, so u squared is 3 squared x squared. Square everything. Okay. If worst comes to worst. Now you might be going, oh, no, I'll remember. But that is a very, very common mistake, so don't do. I'm right on there. That way you don't go look back like, but you wrote it. I also wrote don't do. Okay, and the last one we're going to work on, I'm watching the video. We're at about 17 minutes. And you know what? 18 minutes really. I'm thinking this might be a really good place to stop rather than stopping after these examples, because these examples are going to take it all the way until like 30 minutes. So this is where we'll stop, and we'll start up on the next video here. Good luck on these.